Okay, this is a video to show how we can measure the rate of reaction of surface area. We're going to do it by collecting a volume of gas over time. So this here, our equipment is a gas syringe, so it's measured in millimeters, so it goes from 0 to 100 mil. So we're going to time how long it takes for it to form 100 mil. How we're changing our surface areas, we've got calcium carbonate, and we're going to be reacting it with acid. So in this case we've got 1 molar hydrochloric acid. The hydrochloric acid is an irritant, so I have to be really careful. I'm just getting my hands or on my eyes, etc. So we've got calcium carbonate as a powder. So this is our large surface area, which is a very fine powder. We've got calcium carbonate as tiny little marble chips. And we've got a large chip of marble as well. Calcium carbonate is marble. Okay, all of this is pure calcium carbonate, as pure as it can be. So no extra things made. So first thing we're going to do is we're going to reset the stop clock. So we're going to time how long it takes to get to 100. I will be pausing it on the big ones because it takes about 5 minutes. So we're going to measure out each time to make it a fair test. We're going to measure out 20. Put it in. We're going to add in the powder at the same time. Press the start on the stopwatch, and I don't know if you can see it. Press start on the stopwatch and measure the time it takes for it to hit the back there. So on that goes, press that, start. And you can see this one's really quick, so stop. And we've got 4 seconds. That was very quick. And the syringe only actually reaches 90, so I guess we need to change it to how long it takes to reach 90. So that was the first one. Now we're going to do reset. So first one should put down 4 seconds. So next we're going to put in the marble chips. These have a slightly smaller surface area. You can see slightly finer, but less fine. We're going to put in our 20 centimeters cubed of acid. Reset the stopwatch, get ready, put that in. Ooh. Put that on there, press start, and what I need to be doing is stirring throughout. So how long it takes for it to get. Already you can see we're past our 3 seconds, so it's taken a lot longer with the chips. So the reason is because all the calcium carbonate is trapped inside the center of the chip. So all the calcium carbonate on the outside can react with the acid, whereas the calcium carbonate inside the chip has to dissolve all of the outside before it reaches the very center. Imagine like you're cutting up an apple, the very center of the apple won't get touched until the outer of the apple gets taken away, and we're there. So that was 44 seconds. So our small chips took 44 seconds. Finally, we're going to do it with our large marble chips. So you can see they're a little bit random in size. So these are much bigger. You can actually pick them up. So 20. Reset. Pour it in. Put the stop on. Press start. And shake. So the things that could go wrong in this experiment, it's human error, so how quickly and what order I press the stopwatch and put the lid on, because there's not 2 of me, it's making it quite hard to do it all at once. The other thing is how well I stir it, so you might notice I didn't even have a chance to stir the first one. Stirred the second one, and this one I'm having to stir it. So if I stir it really slowly, you can see the rate that this opens goes down, and if I stir it a lot quicker, it goes a lot faster, so that's an error there. So how well I'm actually stirring it, so I need to make sure I'm doing it exactly the same rate. Another problem is you could get impurities inside your calcium carbonate, so especially with the marble chips, you might not get all of it as calcium carbonate. It could be bits of in your limestone of different sea creatures and all sorts. Could have reacted with some water. There could be some crystals on there. It could be anything. Sometimes we reuse these with acid. We wash them off and use them again. So it could have formed a salt sucrose and calcium chloride on there from the last time this was done. Giving it a good stir. We're nearly there. Stop. So that was 1 minute and 36 seconds. So what you need to do now is convert all of those into seconds and put them in your table. And what we normally do in this experiment is we might, instead of doing it as we just did then, we might measure how much is produced every 10 seconds. So it might be recording how much is produced in 10 seconds, how much is in 20, etc., until we get to 100 mils. We might do it where we measure how much mass is lost, so we could actually do this experiment, and with them on there you can see they're forming a gas, it's fizzing. We could actually put it on the scales, and what would happen is, as the gas is produced, the scale, the volume, sorry, not the volume, the mass of the liquid and the calcium carbonates would decrease as carbon dioxide is formed and goes into the atmosphere. So that's another way. We could actually keep it the same mass if we put like a balloon on top and trapped all the carbon dioxide. So I'm going to stop it there. So this is the first required practical. So changing the surface area and react it with hydrochloric acid.